Hello. Today we will talk about section 3.2, and in 3.2 we're going to talk about truth tables for negation, conjunction, and disjunction. So previously we talked about what a negation was and what a conjunction was and what a disjunction was. Now we're going to look at truth tables. So a truth table is what lets us decide if a statement or an argument is true, when it's true, how it's true, what makes it true. Again, the reason that we do this is because we can take things that may be a little bit ambiguous when you look at it as a sentence in English language, turn it into just its basic variables, right? So we put the letters in so that we have just plain statements, and then we can assign true and false values and make a decision based on that. So the first thing that we need to know is how to set up a truth table. So in order to set up a truth table, we're going to have rows and columns. So these are tables, right? So they have columns and they have rows. Columns go up and down, rows go left and right. The rows we'll start with first because it's the easiest. Basically, to determine the number of rows in a truth table, we use the same formula that we use to find how many possible subsets we could have, right? Because basically that's what we're doing. When we look at the rows, we're looking for all of the possible true-false combinations that we could have for a statement. And so that formula is again 2 to the n power. So before we said that n was the cardinal number, right, the number of elements in the set. This is similar. We're going to say where n is the number of variables. So again, my variables will be the letters that we use for those statements, right? Usually P, Q, R, S, could be whatever letters you want, A, B, C, D, right? Be very careful in MyMathLab, it can use whatever letters it wants. So now that I know how many rows I have, now we need to talk about the columns. So with the columns, unfortunately, there is not a nice formula that just says there will be this many columns, right? The way that we have to determine the columns is to actually look at this statement and break it down. So the way that this works is I need to make one column for each letter, so for each variable. So if I have 2 variables, I'll have those 2 columns, right? If I have 3 variables, those 3 columns, 4 variables, those 4 columns. So I'm going to definitely have to have one for each variable that I have. Then I need one for each negation. And again, the symbol for negation, right, is like this. Of each variable that is needed. So the important thing here is that I need it, right? So somewhere in the statement there is the negation of a letter. If I don't have any negations of letters in a statement, then I don't need a column for it, right? So I don't want to make extra columns and do extra work that I don't need to do. So I only am going to make negations, columns for the negations of the letters that I need. So only for variables that I have a negation of will I make a column for. After I have all of my variables and I have all of my negations of variables, then I'm going to make one column for each set of parentheses. Again, you may not have sets of parentheses. You may just have like if P then Q, right? And if that's the case, then you're fine and you're done, right? But if I have parentheses, I need one column for each set of those parentheses. And then just like I needed one column for each variable and one column for the negation of the variable, I need one column for each set of parentheses and one column for each negation of a set. Again, only that I need. I'm just not going to like negate everything just because I feel like it, or I don't want to do that much extra work. And then my last column will be the one column for the entire statement. So the way that I set up a truth table is the way that I learned how to do this. But if you have taken a logic class previously or know some other way to set up a truth table, that's totally fine. The most important thing that we're going to talk about when setting up a truth table is to always always put the variables in order, right? Alphabetical order from left to right. Always, every time. That way, no matter how you set up the truth table, what order you put the columns in, really won't matter, except for those first columns, right? Those variables must be in order. That way, when we look at the answer column, everybody's answers will be in the same order. It is possible to put them out of order, right? To put them not in alphabetical order and still end up with the right answer. It's just harder to compare because then our true-false values will be in different orders and all that kind of stuff, right? So making sure that it's always in alphabetical order will make sure that when you compare with each other in discussions and that kind of thing, that you all are talking about the same kind of answer, right? So let's go ahead and write that so that we can make sure to remember. Is put letters in alphabetical order. So again, just to make sure that we all know what's going on, when I make a truth table, the first thing that I do is I determine the number of rows by looking at how many variables I have and saying 2 to that power. Once I know how many rows there will be, then I'm going to look for the number of columns. Again, 1 column for each variable, 1 column for each negation of a variable, 1 column for each set of parentheses, 1 column for each negation of a set of parentheses, and then 1 column for the entire statement, making sure always that those variables at the very beginning are in alphabetical order from left to right. So now that we know the basic setup, let's talk about some truth tables. So the first one is the negation. So negation, if I do just a negation, is fairly easy because I only have 1 letter. So since I only have 1 letter, this would be 2 to the first power, which is 2. And so I have 2 rows, right? 1 and 2. The way that this works is I always take the first column and I cut it in half, and then half of them will be true and half of them will be false. So if we remember, negation is the tilde, and this means the opposite. So now I can look at my truth values and I can say, okay, I start out true. I want to be the opposite of true, and the opposite of true would be false. And then for row 2, I start out false, so the opposite of false would be true. So that's probably the easiest one. Usually people don't have a problem with this. You're just taking whatever you have to begin with and you're making it the opposite of that, right? So now let's make a couple of a little bit bigger truth tables here. So those will be disjunction and conjunction. So disjunctions are either or statements. Again, this is an inclusive or for us, right? So disjunction, that's the V. This is or. And so what we're going to look at here is this would be, well, let's start this way. I've got 2 letters. I've got an A or a B, right? So this would be 2 squared, which is 4. So I have 1, 2, 3, 4 rows. Again, I take that first column and I cut it in half. The top half will be true and the bottom half will be false. For the second column, I still have the original half, and then I cut each of those halves in half again. So now I'm going to cut in half here and cut in half here. And then the same thing happens. The first part will be true, the second part will be false. The first part will be true, and the second part will be false. So with an or, in order for an or to be false, both of the original statements must be false. So the thing that we're looking for here is false or false equals false. So this is kind of like Sesame Street a long time ago. You play one of these things is not like the other, right? So we're looking for the one thing that's different here. So the one thing that's different is this line. So I want to see where I have false, false. False, false is only here in row 4. So since those are both false, my answer will be false. Since it's one of these things is not like the other, if this is the false one, everything else will be true. So this would be a good time to make flashcards for this stuff, right? Because you need to be able to remember the rules, right? I prefer to remember just one rule rather than like all 4 of them. So as long as I know that both false equals false, everything else must be true, right? So conjunctions are this symbol, and this is my and. So for and, I need this to happen and this to also happen. So both of the things must happen. So this time when I'm looking at what makes this true or false, I'm looking for that one time when they both are true, because that's when my answer will be true. So again, I've got 1, 2 letters, so 2 to the second power is 4 rows. And then I do the same thing. I cut the first column in half. The top half is true. The bottom half is false. I cut each of those halves in half. And then I cut the top true, bottom false, top true, bottom false. Again, I'm looking for the one time that it's different. And so this is the time when they are both true, right? So true and true equals true. They are both true in row 1, and so this will be my true. Again, one of these things is not like the other, so this is the one that's going to be different from everything else. If this one is true, that means everything else will be false, right? So for false or false equals false, we would say all others are true. And for true and true equals to true, all others are false. Right? So I'm looking for that one thing that's different. I can make that flashcard, I can study it, I can make sure that I remember it. So now let's take this information that we have and put it all together. Very rarely am I going to give you just like what's the negation of A or what's A or B, right? So let's look at some other, a little bit more complicated truth tables. So in example 1, I want to construct the truth table for not, parentheses, not Q or P, right? So again, I need one for every letter, so I need a P, which I have, and a Q. I need one for every negation of a letter, so the only negation of a letter I have is the not Q, so I have that. I need one for the entire set of parentheses, and so that's what's here. And then I need one for all of the statement together, and that's what goes last. I still have 2 letters by themselves, right? 2 variables. So this is 2 squared, and that's 4. So I have 1, 2, 3, 4 rows. Cut that first column in half, and half are true, and half are false. Take each of those halves, cut them in half again, and then the top half is true, false, false. So here we go. The first thing I want to do is negation of Q. So again, negation means opposite of Q, right? So I'm looking only at the Q column, and I want to make it the opposite of that. So I'm going to look here, and I want the opposite, and so that would be false, true, false, true. In the next column, now I have that negation of Q or P. So this time, I'm going from here to here. So I'm linking these two together. This is with an OR, right? So again, for the OR, it's false or false equals false. So I'm only comparing these 2 columns. These are the only columns that I'm worried about, right? So I'm looking for where they're both false. So this one's true, false. This one's true, true. This one's false, false. There's my false, false. This one is false and true. So that means everything else is true. Again, I'm looking for that one thing that satisfies the condition of false or false equals false. And now for the last part, I just want the negation of what I just did, right? So I'm looking for the opposite of the last column we just finished, and so I'm just going to do the opposite of that, and so this will be false, false, true, false. So sometimes in my math lab and on your logic project, I will ask you to give me a description of when your statement is true or not true, right? Always pick what you have least of, right? So I have the least of the trues, so this is the one I'm going to pick. When I ask you to describe this, I always want you to go back to the original variables and tell me what those truth values are, right? So again, this statement was true one time, so I'm going to say my statement is true when, and now I'm going to say what the original truth values are, right? So when P is false and Q is true. So pick what you have fewer of. If you have fewer F's, then use the F's. If you have fewer T's, use the T's. If they're equal, pick whichever one you like better, right? As long as you let me know whether it's true or not true at those examples, right? In example 2, it wants us to construct a truth table for it is not the case that not P and not Q or R. So now we've got 3 letters, right? So we're going to have to first worry about our columns. So we know we have got the 3 letters, P, Q, and R. Now I'm going to look for any negations. So I have a negation of P and a negation of Q. So I'm going to need the negation of P and the negation of Q. Now I'm going to look for any parentheses. So for parentheses, I've got here, and so that'll be not P and not Q. And now I need negation of the parentheses, so now I'm looking for all of this. So negation of not P and not Q. And then for the last part, I want the entire statement. So we'll have the negation of not P and not Q or R. Okay, so here we go. This time I've got 3 variables, so I'm going to say 2 to the 3rd power is 8. So I'm going to need to have 8 rows. All right. I'm going to cut this in half. In my first column, the first half will be true, and the second half will be false. Now I'm going to cut each of those halves in half, and I'll have the top half true, bottom half false, top half true, bottom half false. And then I'm going to cut each of those halves in half again, and then alternate true, false, true, false, true. Let's make that look like a better T. True, false, true, false. So again, the main reason that we want to make sure that we do this in this order is so that all of the answer columns will come out in the same order. This will be especially true in my math lab because my math lab is only going to ask you to put the answer column in. So if your answers are in a different order, then of course it's going to count you wrong, right? So you need to be very careful. Make sure that you have alphabetical order here at the top, right? So P, Q, R, those are in alphabetical order, and then divide your columns up correctly, right? So now we can start doing the stuff. So in the first one, I want just the negation of P, right? So negation of P, I'm going to come back over here to P, and I'm going to do the opposite. So that means that I'll have false, 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 true, 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 true. Next column wants negation of Q. So I'm going to go to the Q column, and I'm going to do the opposite of that. So false, false, true, true, false, false, true, true. In the next column, now I'm going to compare two. I'm going to compare not P and not Q. So I'm looking here and here. This is an and, right? So it's true and true to be true. So I'm just going to go down through, and I'm going to look for where they're both true, right? So both true would be here, both true, and here, both true. So those will be two T's. Everything else will be false. So again, true and true equals true, true and true equals true. Everything else is false. Next column, I just want the negation of what I just did, right? So the opposite of what I just did here. So that means now these will all become trues. And these two will be falses. And now I'm going to go all the way back. So I'm going to take what I just did here, and I'm going to compare that back to R over here, right? So I want this, and I want this. This time, this is an OR, right? So the OR is false or false equals to false. So I'm looking for where they're both false. So false, true, true, false, true, false, true. So the only place that they are both false is down here at the very end. That will be my false. Everything else will be true. To write my statement, again, I'm going to look for what I have the least of. I actually only have the one F down here at the bottom again, right? So this is the one I'm looking for. I'm going to go all the way back to the beginning. And so this one is nice because I can say my statement is true except when. So my statement is true except, right? So except means not true. When P, Q, and R are all false. So now that we have an idea of how to set up an entire truth table, let's talk about how we can look at an individual statement and determine its truth value. So now we're going to talk about words, things that we know are true or false, right? So in example 3, it says 1 million is greater than or equal to 1 billion. So I've got an or. Right. So that means I have two things. I have 1 million is greater than a billion, or I have 1 million is equal to 1 billion. So those would be my two simple statements. And so now I can have my variables, P and Q, and we're going to say 1 million is greater than 1 billion. And then Q will be 1 million is equal to 1 billion. And now I can look at my statement like this as P or Q. So now I need to know truth values, right? So 1 million. 1 million greater than a billion. Would you rather have $1 million or would you rather have $1 billion, right? 1 billion definitely larger than 1 million, and so that means that P is false. So because of what I just said, that 1 billion is definitely bigger than 1 million, right? So 1 million is not greater than. That means that 1 million is also not equal to, right? And so this is also false. And so now I can come back over here and say this is false, and this is false, and then by my rule, false or false equals false. And so the entire statement, 1 million is greater than or equal to 1 billion, is false. And this is something that we should have already kind of known, right? Just by knowing what 1 million and 1 billion is, that it was a false statement. But this is how you prove it, right? So now let's take something that looks totally weird, and we're going to do something very similar to that, right? So I've got Angelina Jolie is an actress, Zac Efron is a janitor, but Johnny Depp is not a plumber. Okay, so P, Angelina is an actress. We're going to call this one true, yes. Then I've got Q, Zac is a janitor. He might play one at some time in a movie or something like that, but he is not actually in reality a janitor, so we'll call this one false. And then I've got Johnny Depp is not a plumber, right? So Johnny So if I say Johnny is a plumber, that's also false, right? Not currently today is he a plumber. Maybe sometime in the past he was a plumber, but not right now, right? So now when I look at what I have, I've got P or Q, comma, right? So that means that's all in parentheses. Or, that's this one, but be careful, that's like my and, right? So this is and. Johnny Depp is not a plumber, right? So we're saying not are. So we're going to break this down. Again, order of operations, I go inside the parentheses first, right? So P, we said is true, or Q, we said is false. So again, false or false equals false. It's not false or false. That means this one is true. We said that R was false, so not R would be true. Now we've got true and true, and that is always equal to true. So even though this is a very weird and strange sounding sentence, it is actually a true statement, right, based on logical reasoning.